We will cover Prasanta Chandra Mahalanobis's contributions to statistics, development of the Mahalanobis distance formula, understanding Mahalanobis distance, and pioneering work in sample outlier detection in agriculture, Mahalanobis distance formula, practical application, and pioneering work in sampling theory in this video. One of Prasanta Chandra Mahalanobis's notable contributions to statistics is the development of the Mahalanobis distance, a measure of the dissimilarity between two data points in a multivariate space. This distance metric is particularly useful for identifying outliers and assessing the similarity of data points across multiple dimensions. The Mahalanobis distance is defined as follows. The Mahalanobis distance formula for two data points and a dataset within variables is as follows: dx at a dx a, where dx a is the Mahalanobis distance between data points and I, as a is the vector difference between x and I. S is the inverse of the sample covariance matrix. The Mahalanobis distance is a valuable statistical tool used in various fields to measure the dissimilarity between data points while considering the underlying correlation and variability in multivariate data. In the Indian context, it finds applications in several areas, including economics, healthcare, and agriculture. Suppose you are an agricultural researcher in India studying the growth of different crops. You have collected data on factors like soil nutrient levels, temperature, and rainfall for various regions across the country. To identify outlier regions where crop growth significantly deviates from the norm, you can use the Mahalanobis distance. The formula for Mahalanobis distance was mentioned earlier. dx ES represents the data point you want to analyze. E is the mean data point representing the average conditions, and S the sample covariance matrix. In the agriculture example, you can calculate the Mahalanobis distance for each region's data point from the mean I to assess how different the region's crop growth conditions are compared to the average conditions. Regions with high Mahalanobis distances may indicate potential outliers where further investigation or intervention is needed. Mahalanobis pioneering contributions to sampling theory, which involves the selection of a subset sample from a larger population universe to make statistical inferences about the population. His work laid the foundation for the design of efficient and representative sample surveys. The key idea in Mahalanobis's sampling theory is the concept of stratified sampling, where the population is divided into homogeneous subgroups, strata, and samples are drawn from each stratum to ensure better representation of the entire population. This approach reduces sampling errors and improves the accuracy of statistical estimates.